In our exploration of hydrothermal systems, we learned that nature needs three key ingredients to create a geothermal engine: a heat source, a cap rock, and crucially, a porous reservoir rock to act as the boiler. But what happens when you have immense accessible heat locked away in solid rock with no natural pathways for water to flow? Do we just walk away? Not anymore. The reality is, most of Earth's heat isn't in perfectly arranged hydrothermal systems. It's stored in vast volumes of what we call hot, dry rock, rock that is incredibly hot but impermeable. This is where we stop being passive explorers and start becoming active engineers. We use a groundbreaking technology called Enhanced Geothermal Systems, EGS, to create a reservoir where nature didn't. So how do we engineer this reservoir miles underground? The process is a marvel of modern engineering. First, we drill an injection well deep into the hot, dry rock. Next comes the enhancement. We pump water down at high pressure, causing the rock to fracture and create a network of interconnected pathways. This process, called hydraulic stimulation, creates the permeability that was missing. Then, we drill a second production well a short distance away. Now our system is ready. We circulate water down the injection well. It flows through the newly created fracture network, absorbing intense heat from the surrounding rock, becoming superheated water. This superheated water is then brought back to the surface through the production well, where its energy is used to drive a turbine, generating electricity. This is what makes EGS a true game changer. It fundamentally decouples geothermal energy from the strict geographic limits of natural hydrothermal sites. For decades, large-scale geothermal power was chained to geologically active regions, the Ring of Fire, continental rift zones, places with obvious surface clues like geysers and hot springs. EGS shatters that paradigm. By giving us the ability to engineer our own reservoirs in hot, dry rock, it potentially makes geothermal power accessible almost anywhere in the world. Think of what that means. Countries far from tectonic boundaries, or even entire continents, once considered to have low potential, can now look beneath their own cities and landscapes for a source of clean, constant, homegrown energy. It has the potential to unlock geothermal energy on a massive global scale, turning it from a niche regional resource into a foundational clean energy source for the world. Of course, this frontier is not without its challenges. The initial cost for the deep drilling and infrastructure required for EGS can be significant. Furthermore, hydraulic stimulation must be carefully engineered and monitored to manage the risks of induced seismicity or small man-made tremors. However, with continued investment in research and development, scientists are pioneering new drilling techniques to lower costs and refining monitoring systems to ensure safety. Enhanced geothermal systems represent a perfect intersection of geology and human ingenuity. Instead of just searching for nature's engines, we now have the tools to build our own. It proves that the limits of our resources are often just the limits of our technology. And it is this very technology, the spirit of engineering the Earth itself, that opens the door to tapping into even more powerful and unconventional resources, which we'll explore next.